let's discuss a topic called nitrogen heteroaromatics. Okay, what in the world are nitrogen heteroaromatics? Well, this is a branch of what's called heterocyclic chemistry. Some people might say heterocyclic. What is a heterocycle? Well, hetero means different, and cycle or cyclic means ring. What this is really, the different in the ring is really to say that the ring consists not just of carbon atoms, but atoms that are different from carbon. So that would include atoms like nitrogen and oxygen and sulfur, and actually include crazy stuff like tin. We won't talk about this. We're specifically going to focus on the left here, nitrogen heterocycles. So heterocycles that contain nitrogen, and furthermore, these just aren't any ring. These are all going to be aromatic rings. So let's see some examples of nitrogen heteroaromatics. These are all going to be rings that are aromatic. So here's one. Here's pyridine. We'll draw 4 more. These are kind of the simplest ones because they have the fewest number of heteroatoms. So pyridine, this is called pyrrole. Maybe we'll fit them all across this one row. This is called oxazole. Here is thiazole. Kind of a theme going on here with the OLE suffix. This is called isoxazole. Now, there are a lot more heteroaromatics than just these 5, but these are typical examples. Now, as it turns out, these compounds may be less so pyridine, but the other ones, these 5-membered rings, they're pretty easy to make. And as you look at these structures, you see functional groups that we've encountered before. So on the pyrrole, I am circling a group. That group, the nitrogen with a single bond to a carbon-carbon double bond, that's an enamine. And in oxazole, you can see an imine. And actually, when we talk about making these compounds, it's really going to come down to making enamines and imines that form a 5-membered ring or maybe larger ring. The driving force in making these compounds is that we're going to form an aromatic ring. So in making enamines and imines, we take an amine, be primary or secondary, and we'd treat it with a carbonyl compound, and we'd set up an equilibrium, and we might make an imine. That's if we had a primary amine, or we'd make an enamine if we had a secondary amine. And we'd always form water. This reaction is in equilibrium, and we need to do something, add or remove water to help affect the position. Well, as it turns out, these nitrogen heteroaromatics, the product is much more stable because it's aromatic. So that these equilibria typically always favor the right-hand side. So they're really very convenient reactions to run. They tend to be very old chemistry. I'm talking like even 1890s chemistry, because it was simple chemistry and it was very easy for people to perform. And a lot of that chemistry was discovered early on because it was easy to do. So we'll spend a few videos talking about how you make nitrogen heteroaromatics. Not all of them, but just some of the most common ones.